Welcome to a new lesson of the course. In this lesson we are going to write our first function in assembly code. Let's create a new project called PO4ASM from the project PO3GPIO. Open TrueStudio. Import the new project into TrueStudio as in previous lessons. As we have copied the project from an existing one, there are some useless files that we can delete. Let's build and debug the program to make sure that it works. We do this because later on we are going to add assembly code and maybe the program will not work properly. The program blinks the LED LD2 correctly. Let's create a new file in the folder source. The file name is going to be asm.s. The extension S means that it contains assembly code. This is the content of our file in assembly code. This first line means that we are going to use the unified syntax. This is the modern way of writing assembly code for ARM MCUs. The second line means that we are going to use thumb instructions, that is the instruction set for this MCU. The directive.text means that this section contains initialized data and/or instructions. With the directives.func and .enfunc enclose a function, in this case called ftestasm. With .global we let the function ftestassembler be accessible from outside this file. On the line number 10 we set a label with the name of the function to set the beginning of the function. With the instruction moveX we load to the register R0 the number 171 in decimal. The symbol hashtag means that it is a literal. This line loads the register R1 with the same value, in this case written in hexadecimal. This line loads R2 with the same value but written in octal. Finally, we load R3 with the same value but this time written in binary. With this line the function ends and the program comes back to the file main.c. In the next lesson we will see this mechanism more in detail. There is an ARM standard called AAPCS that explains how the C compilers handle the registers and the stack when they call functions. The CPU Cortex-M0 has 16 general registers that we will see in detail during the course. Out of them, the registers R0 to R3 and R12 can be used freely inside our function without the need of saving restoring their content. The instruction moveS has as first parameter a register, from R0 to R7, and as second parameter an 8-bit number, from 0 to 255, that copies to the register. This instruction is encoded in 16 bits. The idea is to copy the value 171 to the registers R0 to R3 but using different notations. In hexadecimal we will use 0xAB. In octal it would be 0253. I've never used this notation. Finally, in binary you would write 0B 10101011. To be able to use the function defined in asm.s in main.c, you must add the function prototype to main.c. The prototype contains the type that it returns, the name of the function and its parameters, ending with semicolon. I am calling the function before the infinite loop. Let's build the project and start a debug session. I am placing a breakpoint to the line 69 before executing the function fTest_asm. Start the debug session. The program has stopped on the line 69. Go into the function fTest_asm. We are going to open the window with the CPU registers. These are the general registers of the CPU. In our program, we will modify the registers R0 to R3. These are the buttons we use in the debugger. This button is for restarting the MCU. This button is resume, to run code until the next breakpoint. During the execution, you can pause the MCU with this button. With this button you can terminate the debug session. This is for terminating the current debug session and start a new one. With this one, step into, you make a step, executing a line of source code. If it is a function call, you will go into the function. With this one, step over, you also make a step, executing a line of source code. But if it is a function call, you will not go into the function. The function is executed without stop. Finally, if we are inside the function, we can get out of it with this button, step return. Let's execute the line 11 with the step over button we have seen. The value 171 is loaded to the register R0. As we have run an instruction, the register PC program counter has changed. 0xAB 171 decimal is loaded to register R1. You can see how R1 and PC are updated. The next two lines do the same with R2 and R3. At the end of our function, the registers R0 to R3 have the value 171. The last instruction is to get out of the function and come back to the main program. We will see it in detail in the next lesson. Now the infinite loop is blinking the LED. Our function in assembly code did nothing wrong and the main program is running correctly. The LED blinks every second.